Hi guys, today is our first day of Understand the Chemistry. Our topic is Thermodynamics. My name is Dev and welcome to our channel Cam Dev. So, we would like to understand any process, we need to study the system, right? What is system? We are going to do that. If we want to study the system in terms of electron flow, then we will study reaction mechanism. If we want to study the system in terms of energy levels, then we have to study quantum mechanics. If we want to study the system in terms of rate of reaction, then we study system as chemical kinetics. But if we want to study the system in terms of heat transfer is going there, then we have to study it under thermodynamics. One more, I will give you one more explanation for that. So, if we want to trace the exact path of the electron are taking, who attacks whom and where the bond breaks, we study reaction mechanisms, means we have to track the electrons. So if we want to know how fast the process is happening, is it taking 1 second or 100 years, we study chemical kinetics. If we want to zoom into the smallest level or the energy levels of the individual molecules and atoms, then we have to study it as quantum mechanics. But if we don't care about the path, we don't care about the speed of the reaction, if we simply want to know that will this reaction will happen or not, if it will happening, then is it stable or not? So this thing can be described, explained by the thermodynamics. So here is the thing, thermodynamics. So thermodynamics is made up of like two words itself. The one is thermo and the other one is dynamics. So thermo means heat. Heat is a form of energy, you know that. And dynamics is motion. Means branch of the physical chemistry in which we study flow of heat, yeah, transfer of heat in between system and the surroundings is called as thermodynamics. So now there are two terms. The one is system and the other one is surrounding. So what is system? The part of the universe which we selected for investigation is called a system. Means if you want to know anything, so you have this system. So to know the thing, to know the process, we need to study the system, this thing. Other than this system, the all over the universe is called as surrounding. So this is system, the other one is surrounding, and the thing that is separating from system from the surrounding, this thing is called as boundary. Boundary means limit that will separate out the system and the surrounding, that is called as boundary. So part of the universe which we selected for the investigation of the process is called as the system, and the rest part of the universe is called as surrounding. So and the boundary is a wall that differentiate system and surrounding itself. So now the boundary part. So boundary can be real or can be imaginary. We will know about it. just wait. So, boundary can be real or like imaginary. So, exchange in between system and surroundings or where the work has been done, that's all activities done on boundary. So, boundary, why it is so important? Because the transfer of the energy which we are talking in thermodynamics is actually is going on the boundary itself. So all the reactions, all the things we have to talk about in this topic. So all the heat transfer is going on the boundary itself. Okay, so now the boundary part. So boundary can be rigid because it also be real now, non-rigid. It may be heat conductors like diathermic wall or non-conductor of heat like adiabatic wall. So now we have to move forward. So now we study about the system first. The system has three types. The one is open system, second one is closed system, third one is isolated system. So we have to make some diagrams for it. So as we know, this is the system. And the outer world is over the surroundings. So in open system, there are just two things actually that can be transferred. The one is the heat and the second one is mass. One is heat and second one is mass. One is heat and the second one is mass. So in the open system, so imagine that it is like a glass of water. So if the glass is open now, then we can transfer the heat also, like through warm it on the gas or the stove, anything. So we can transfer the heat, of course, and we can transfer the mass also. So we can pour the water into it, or we can also put that down the outside. So, and the other one, in the closed system, now the lid is on. So heat can be transferred, but mass can not. Heat can be transferred because it is not isolated. That's why. So heat can be transferred through it, but not mass actually, because the lid is closed. Lid is on. Open system, in open system, the lid was off, so we can transfer the mass. But in isolated system, we cannot transfer heat. We cannot transfer mass. Why? Because isolated system has adiabatic walls. So what they have? They have adiabatic walls. Adiabatic walls are the walls that not conduct the heat through the system. Means heat traps in that system. It do not transfer to the surroundings. So adiabatic walls. So here heat can be transferred and mass also can be transferred. Here heat can be transferred but mass not. Here not heat and not mass can be transferred. Okay, next. So whenever there is we are discussing heat, so there is also discussion of work has to be done, because work is what? Work is the energy consumed, and after that the output is the work. And if the work has not done, then it is changed into the heat itself. So have you the engine now? So car engine, if it get heated, then the efficiency of the engine will be slowed down or decreased. If the car engine is silent and do the things that cannot be heat too much, then the engine is very efficient. So in the open system, जो आपका वर्क है, so work performance present means work has to be done here. In closed system also the work performance is present, but in the isolated system the adiabatic walls are there, so work may or may not be present. Why? We have to do it separately. So now we are working on the fundamentals of the thermodynamics. So now, for example, we take n moles of gas in a cylinder. Okay, so then the cylinder is the boundary. The cylinder itself, the iron cylinder, is a boundary that separate the system, means gas, from the surroundings, means your environment. So here system is what? System is gas, cylinder is the boundary, and the surrounding is your environment. So the gas in the system, because when we increase the temperature or pressure, the gas temperature also increase, also it is also affected. So this means gas properties are depending on the activities when we do the system on fire. Means when we affect the system, when we want to be affect the system, the things are going through the boundary itself, right? So for example, open system, for example, river, wells. Examples of closed system, example water in a bottle, etc. Isolated system examples, isothermal flask or vacuum flask. Vacuum flask is what? The bottle has the copper thing, and there is a vacuum, means air, and after that the another material is covered on it, so it is called a vacuum. So the air between the copper and the outer material is work as a non-conductor of heat, so heat get trapped, work as adiabatic wall. So we generally assume that in a isolated thermos any material remains heated or cooled for the long time or the infinite time, because the adiabatic walls are there now, so they cannot transfer the heat. We studied that now earlier. So heat transfer is not possible there. So what should be done? It should be that heat is not transferring, means Heat is not going out towards the surroundings or the outside the system. So it should not get be cold after some time. But you know that it is not going to happen, right? We all have hot pots where the chapatis are formed under the lid, but after some time it also get cold. Your tea or coffee in the thermos also get cold. So why it is happening? Because of it is not the correct, because temperature of any like material in a matter of is a matter of internal energy. We will discuss is further when we go through the thermodynamics, other other processes and other things. So the internal energy is depends on the various factors, just like kinetic energy, potential energy, and many more things. So when internal energy increases, temperature also increases, and the when internal energy decreases, temperature also decreases. So heat is just a factor of internal energy. Heat is just a factor of internal energy, means if the internal energy of the molecules are increasing, the heat is also increasing. So the when a heated material kept in isothermal flask covered with like insulated caps or something, then for some time one temperature remains constant, and after some time the particles of the system, means of the thing, begins to drop a little bit, because all the molecules are there collide with each other and to the walls, and this makes internal energy decrease, so the temperature also decrease. That's why the system temperature decreases by with time. So like we can do maintain the temperature for the like long time, but not like for forever. Of course, yeah, we can you can see that in the Amazon and the Flipkart there is a guarantee of 10 to 12 hours of hot and cold beverages, but not for more than that. So now we have some tips through it. So when there is a reactant in gaseous state, then the system should be closed system. There are some like tips to gas the system actually, like which system is used when. So if the system is made up of any gaseous state, then the system should be closed system, otherwise the reaction would not be completed actually. So because without closed system, reaction can not be completed in gaseous state. If the reaction is holding due to the heating, then the reaction is not isothermal or isolated, because in isothermal or isolated heat transfer नहीं होता है. There is no heat transfer in isolated or isothermal reactions. If there is a product in gaseous state while reaction is reversible, then the system is not closed system. If the product is in the gaseous state while the reaction is reversible, then the system is in the closed system. Otherwise, gaseous state, if there is a gaseous state and the product is gaseous, then it will flew away, and now the product is not there, then how is it possible to get reversed to the reactant again? So it cannot be a reversible reaction then. So so product described as gaseous state, and we denote it as this increased sign. Then it means that system is open type of system, so that gas can pass out. So for example, we are doing things like, see, for example, the reaction CaCO3 CaO and CO2. So if there is possibility, so here you can see this sign, it is a sign of heating, so it cannot be adiabatic reaction, adiabatic system. It cannot be a diabetic system because it is transferring the heat actually. And here see the reactant is what? Solid. It is not gas, right? And the product is gas, but there is no reversibility options there. Reversibility option is like this, means reactant changes into product and product mixed and then changed to the reactant again. So there is not any type of reversibility. So if the reactant is solid, then it is open system. It cannot be closed because it is not a reversible. It cannot be adiabatic because it is showing heating, right? And adiabatic mein there is no transfer of heat, so it is a open system. So another example, for this we used to do, for example, now we will write it as, now if we write this like this, CaO CO2. See, so if this is the reaction, now there is showing a reversibility factor. This sign is for reversibility, right? So is there a sign of reversibility, means it cannot be open system. Open system cannot be open system, because if there is open system, then the gas is in the product itself, it will flew away now. Then when the CO2 is not there present, then how they will make the reactant? So this should be closed system. Okay, so I think I have given you the examples that is necessary for this. So now the next topic is thermodynamic microscopic property. Thermodynamic or microscopic properties. So thermodynamics is used for the bulk things, means it cannot be used for the single atom or single particle or the single molecule. For that we have quantum mechanics, right? So for the bulk we use the thermodynamics, and thermodynamics is for macroscopic. It is for the macroscopic. What is macroscopic? There are two things. Microscopic means very tiny, very small, like atom, molecule, etc., and macroscopic, like made up of those microscopic properties or microscopic particles. So that is macroscopic. So thermodynamics is for the microscopic properties. But if we want to study the microscopic properties, then we have to move to the statistical thermodynamics. Statistical thermodynamics is the thing where, here also in statistical thermodynamics, we also study the bulk particles, but these particles are microscopic. And now we are doing what? We are doing study of macroscopic properties. Means, of course, we are dealing with the bulk, but these particles are group of particles or the group of things. Okay. So from now we will discuss is in the another lecture. So today it is like much for today, and I will upload another lecture. I think two lectures in a week. But if it will get smoother, then we will try to, like, for the daily one lecture. But I don't think it will happen soon. So but I can promise you two lectures in a week. Thank you so much. Hope you will like it. Please like, share and subscribe.